Hello all. Now this is the fourth lecture in this cam and follower. This will be the last lecture in this particular chapter. We have already discussed different types of follower motion and the different types of followers and the way in which the followers can be aligned with respect to the cam. In this lecture, we will discuss about two more types of follower motion. One is the uniform and equal acceleration retardation motion, and the other is the cycloidal motion. We will discuss a problem on this type of motion. We will try to draw the displacement diagram of the follower based on this type of motion, and then we have to draw the cam profile. Since the procedure to draw the cam profile is already discussed, how to draw the cam profile of this particular question will not be done by me. That topic will be given to you as a graded assignment. So the cam profile you need to draw and you need to submit as a graded assignment. Only the displacement diagram will be discussed in this particular session. A cam is to give the following motion to a knife edge follower. Follower to move outwards through 50 mm during 120 degree of cam rotation. Follower to dwell for next 60 degree of cam rotation. Follower to return to its starting position during the next 90 degree of cam rotation, and the follower to dwell for the rest of the cam rotation. The minimum radius of the cam is 50 mm. The follower moves with uniform and equal acceleration and retardation during the outstroke with a cycloidal motion during the return stroke. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. So this particular question is similar to what we had solved in the previous classes. The only difference is regarding the type of motion of the follower. Here in this question it is given that the follower moves with a uniform and equal acceleration and retardation during the outward stroke and with a cycloidal motion during the return stroke. So these are two types of motion of the follower. Uniform acceleration retardation motion means in the same stroke the follower will have both uniform acceleration and retardation. Till the middle of the stroke, from the starting point it will be an uniform acceleration, and later from the middle of the stroke to the end of the stroke it will be uniform retardation. So that is the type of motion. Now we will discuss how to draw the displacement diagram. Most of the procedure to draw the displacement diagram will be similar to that we had discussed before. A cycloidal motion is defined as a curve that is traced by a point on the rim of a circular wheel such that the wheel moves in a straight path without slipping. You can see from this particular animation that this is the point, this is the path that is traced by the point. It's a path that is traced by the point which is on the rim of the path, rim of the wheel, circular wheel, and the wheel is moving in a straight path. Now we will discuss how to draw the displacement diagram. So the procedures are same as before. First you need to draw the x-axis which represents the cam angle, the total angle of 360 degree, and the y-axis represents the stroke of the follower, the stroke length of the follower. You can use the same scale that you have used in the previous question. First, as you know, we have to divide the cam angle into the various regions of follower motion. The first is the outstroke, which is for 120 degree of cam rotation, and then you have the dwell period, which is for 60 degree of cam rotation, and then third is the return stroke, which is for the 90 degree of cam rotation, and fourth is the second dwell period, which is again the remaining 90 degree of cam rotation. After dividing the cam angle into the various stages of follower motion, now we need to start drawing the displacement diagram. Regarding the outstroke, the follower is moving with a uniform acceleration and deceleration. Now we will discuss how to draw the displacement diagram when the motion is uniform acceleration and deceleration. For that, we need to first divide the outstroke region into 6 equal parts. Once you divide the outstroke region into 6 equal parts, then after that, you take the middlemost line in that division, you divide that line also into 6 equal points, okay, 6 equal parts, and each point of division you mark with Roman letters, and in the outstroke region each point of division you mark with starting from 0 to 6, like we had done in the previous case. After that, you mark this particular point as small f. Then what you do is you join A with 1, A with 2, A with 3, then 4 with F with 4 and F with 5. Okay. After that, you can see that line A1 intersects the vertical line from 1 at A. Here you can see clearly line A1 intersects the vertical line from 1 at A. So you mark point A there. Similarly, line A2 intersects the vertical line from 2 at B, and similarly A3 intersects the vertical line from 3 at C, and here line F4 intersects the line from 4 at D, and line F5 intersects the vertical line from 5 at E. Okay. So you now got all the intersecting points. After that, you join all these intersecting points using smooth with free hand. Okay. So finally you will get this curve. Okay. So this is the displacement diagram of a follower which undergoes uniform acceleration and retardation. After the follower undergoes the outward stroke, the follower remains at the top of the stroke, which will be the first dwell period, and as you know from the displacement diagram, the first dwell period will be the region from F to F prime. So this point will be F prime. That will be the displacement diagram of the first dwell period. After the first dwell period, the follower undergoes the return stroke, and in this case the return stroke is per the cycloidal motion. We have already discussed that cycloidal motion is defined as a curve that is traced by a point on a circular wheel such that the wheel moves in a straight line or a straight path. In this particular case, in the case of cam profile, the circumference of the circle will be the stroke length. So you can write stroke length, you can write the equation stroke length S equal to 2 pi r, where r is the radius of the circular wheel. this equation is very important. When we discussed about drawing the displacement diagram of the follower during cycloidal motion, this equation we will use this equation. Now to draw the displacement diagram of the return stroke, which is based on cycloidal motion, like we have done in the outstroke region, we have to divide the return stroke region into 6 equal parts. And from each divisional point, we need to draw vertical lines. You can label each division like I had divided here. Now after dividing the return stroke region into 6 equal parts, we need to draw a circle which is known as the rolling circle at this particular point, and that point is actually f prime. This is what I had told you. This is the rolling circle whose perimeter will be equal to the stroke length. So with stroke length, which is equal to 50 millimeter, you can write the equation as S equal to 2 pi r. From this equation you will get the radius of this circle, which will be equal to r equal to S by 2 pi, where S is the stroke length, which is 50 millimeter. And from this equation you will get the radius of this circle, of the smaller circle, which is a rolling circle, as approximately 8. Okay, so with 8 as radius, you draw this smaller circle, 8 millimeter. After drawing the rolling circle, now we need to divide the rolling circle into 6 equal parts. That means you take an angle of 60 degree with respect to this horizontal and then mark each point. So that is, you start from 1, 2, 3, 4, 5, 6. In this way, you take 60 degree each and divide the rolling circle. After dividing the rolling circle, you join 1 and 2. Similarly, join 3 and 4 and 3 and 6, and join point 5 and 4. When you join these points, that is, for example, when you join 1 with 2, that horizontal line will intersect this vertical line, which forms the diameter at this particular point, and that point can be named as G. Similarly, the horizontal line 3, 6 will meet the vertical diameter at f prime, that is already there, and similarly the horizontal line 5, 4 or 4, 5 will intersect the vertical diameter at h. Okay, so this point you can take it as h. After labeling, now you join f prime with E. That will be this line. After that, from G you draw a line parallel to line f prime E, such that the line intersects these vertical lines. And similarly, from H you draw a line parallel to f prime E, such that it intersects the whole vertical line. We will see that the parallel line from G intersects the vertical line from 1 prime and 2 prime at points A prime and B prime. And similarly, the line f prime E will intersect the vertical line from 3 at C prime. Okay, so you label that point also. Similarly, the line from H will intersect the vertical line from 4 prime and 5 prime at D prime and E prime. So now you have now got all the points Now after that you need to join those points starting from F prime with free hand. Okay, so you join F prime, E prime, D prime, C prime, B prime, A prime and E. And now what you get is the displacement diagram during the the return stroke region. After drawing the displacement diagram of the return stroke region, the follower will be in the second dwell period, which will be at the lowermost position of the stroke, which will be a horizontal line. So you draw a horizontal line, and now this will be the displacement diagram of the follower. I have completed drawing the displacement diagram. Now the cam profile you have to draw based on the question. So the procedures to draw the cam profile is already discussed. Based on that you can complete drawing the cam profile for this particular question. Now there are two more questions that you need to do, which are similar to the questions you have done before. So this is the question. Here in this particular question, all the motions of the follower is same to that of the last question. Only difference is that in this particular question the follower is a roller follower, and I forgot to mention the radius of the roller. You can take the radius of the roller as 35 millimeter. Okay, sorry, the diameter of the roller to be 35 millimeter. Okay, so that you please add in this particular question. So based on this you draw the cam profile. And the next question is the same, similar to the previous questions that you had done. Here the type of follower is the knife edge follower, and here the difference is the line of stroke of the follower and the axis of the camshaft is separated by a distance of 25 millimeter. Okay, so based on these two you do the cam profile. Okay, so that means you need to draw 3 cam profiles and submit it as a assignment. This time the assignment will be a graded assignment. Each cam profile will carry 5 marks.